Alright, so this is the final week of me not being there, so last time I had to record some videos for you guys. So going over this warm-up, we want to use the graph to determine the solutions for both of these equations. So graphing the first one, the only thing that really is different between it and the parent function is that the -4 is there, so it's just shifted to the, or shifted down 4, and that's about it. So our parent function, remember, is just a parabola, something like this. Just a quick sketch of it real fast, but for the one we're going to look at here, we're going to actually graph it a little more legitimately. Of course, you can always use Desmos or something like that to make this a little bit easier, but we're only shifting down 4. So our new graph is going to be down here at 4. And then it's going to go to the right 1 up 1, to the right 2 up 4. And that's going to give us our solutions right there. So our solutions are at x equal to 2 and x equal to -2. The next one, not so easy to do. So really kind of graphing this using technology is going to be your best bet. So using Desmos, of course, is going to be the easiest one because it's free, available everywhere. But if you happen to have a TI calculator, don't be afraid to use it. But when you do that, you're just looking for where it crosses the x-axis, just like we did in that last one. And we get two answers, again, x equal to -3 and x equal to 1. So again, basically just graph it and look for where the graph is crossing the x-axis. And that'll help you out with your solutions. So today we're going to look at factoring. So this is where you're going to have some situations where, unlike our warm-ups, where the graphs don't line up nicely and pretty, but this is going to be giving us some ways to counteract that. And we're also going to look at imaginary numbers, right? So in your mathematical careers, you've only experienced real numbers so far, but of course, real, just like whole numbers and fractions, are opposites of each other. There's also an opposite to real numbers, and they're imaginary numbers, or complex numbers, depending on how, well, unfortunately, complex you want them to be. And we're going to look at complex conjugates as well. So first things first, we're going to look at how to multiply binomials using FOIL. There are a few different methods to do this instead of just using FOIL, but I prefer FOIL. But if you're interested in those other methods, just let me know and we can look into those later on. So FOIL here just means the first, outer, inner, last. So FOIL, F first, O outer, I inner, L last. And that's just telling you which numbers you're going to multiply together. So our first one here, it's in sentence form, and we're going to turn it into a quadratic. So it tells us that our roots, or our solutions, are 1/2 and -5. So that means we need to come up with our two binomials from that. So when you're algebraically solving a system or a quadratic, you're going to set each factor equal to 0. So this basically means that our x is equal to 1/2 and x is equal to -5. We're going to work this out to where it's no fractions anymore on both of them and equal to 0. So the left one we're going to multiply by 2 first to get rid of the fraction. So then we have 2x equal to 1, and then we're going to subtract 1 from both sides. Because again, we want it equal to 0. So that's going to be 2x minus 1 equal to 0. And then the right one is just one step. We just have to add 5 to both sides. Fairly simple. So then we have x plus 5 equals 0. So those are our two binomials, and now we have to multiply them together to get our quadratic equation. So what we do is parentheses in parentheses, 2x minus 1 times x plus 5 equal to 0. Because if one of them is 0, the whole thing's 0, right? So now we're going to use FOIL. So we're going to go first, outer, inner, and last. So for those first two, 2x times x. And then the outer, we got 2x times 5. The inner, we have a negative 1 times x. And then the last, now I'm breaking this down very, very minute steps here. I'm not going to do that every time. It's negative 1 times 5 equals 0. So multiplying these, 2x times x is going to be 2x squared. 2x times 5 is going to be 10x. And negative 1 times x is a negative x. And negative 1 times 5 is negative 5. So we do have some terms we can combine together, so some like terms to combine. That's the 10x and the x, and the negative x. So our final solution here is going to be the 2x squared plus 9x minus 5 equal to 0. And that is standard form for a quadratic, and that is the standard form of quadratic with 1/2 and negative 5 as its roots. Now, you could also multiply one of these by some number if you wanted to make it bigger. It's not necessary, but you could. It says write a quadratic, not the quadratic. There are multiple that would go through those points. So just keep that in mind. But all that would do is just mean that we're going to be stretching it or compressing it, depending on which way you go. So the zero product property, that's basically what we just used. We know that if a, b equals 0, then either a equals 0 or b equals 0 or both equals 0. So if you have x plus 3 times x minus 5 equals 0, then either x plus 3 is equal to 0 or x minus 5 is equal to 0. So that's just going backwards from what we just did. So this one we want to factor the greatest common factor. So we're going to factor out everything that we can from it. So the first thing we notice is that 9 and the 3 in the front can factor out, right? So that means we have 3 times 9 divided by 3 is 3, y squared plus y equal to 0. And then we can also factor out a y in both, right? There's at least one y in both terms. So we can take that out. So it's 3y times 3y plus 1 equal to 0. So now we have it broken down into its two factors. And now we can just go ahead and set them equal to 0. So we have 3y equal to 0 and 3y plus 1 equal to 0. 3y equals 0, we're just going to divide by 3 on both sides. That's not going to do anything because 0 divided by anything is 0. So it's y equal to 0 is one of our solutions. And then the other one, we're going to subtract 1 from both sides. So we have 3y equal to negative 1. And again, we're going to divide by 3. And we get our y equal to negative 1/3. That's our other solution. The next one is for you guys to try.